Hello everyone. I've made a new major release for my Unity asset AIS Pro. This video will serve to communicate the new features and document the asset briefly. A detailed PDF documentation is part of the asset, and the practice range can be downloaded and played so you can try out the product yourself. See the link in the description and on the asset store page. In this video, I will discuss the package's key features, compatibility, showcase the demo scenes, and present some examples to integrate this to other Unity third-party packages where automatic integration is not possible. First and foremost, if you already own the package, this will be a free upgrade that will contain breaking changes. If you have the package in your project already, make sure to do a backup before you update. New in version 2.0. Added a practice range, 2 scenes for Cinemachine and 1 without, with configuration controls and various enemies including strafing targets and the grid shot to try out the settings. All AIMSs that change look rotation now return a new struct called rotation that represents the shortest rotation as an addition to the axis, pitch and yaw. Unity's input system is required to run all example scenes at the time of this release, although the code uses preprocessor guards around these, so the package won't fail to import without it either. Added an automatic rotational integrator to implement the rotation changes from AIMSs that calculate that. Added an AIMSs input processor to implement any input modification changes from AIMSs that calculate that. Added improved support for Cinemachine 2 and 3 and without. Added an option to interpolate the resulting calculations for improved smoothness at the expense of accuracy. Target selection is now on a per AIMSs basis, so different selectors for different AIMSs are now an option. Target selection is available in a cone shape too, in addition to the previous sphere selector. Target selection can be set to progressively narrow down if a target isn't found. This helps finding targets around tight cover. Added reticles that show the AIMS's area of effect and change color if a target is found. Drawing gizmos in editor is updated with configurable properties, 1 per AIMSist, and those change color too in play mode when a new target is found. This should also help debugging. Updated the caching to save performance for large projects. Added a 6th AIMSist, motion tracker, more about it later when I detail the AIMSist functionality. Precision aim has improved accuracy around targets with a large hitbox. Auto aim has built-in support for inverted axes. Targets can now define their location based on collision data or an arbitrary point as well. Overriding an AIMS's settings is available on a per-target basis, so individual targets can demand their own AIMS's properties. Context windows for a quick setup are now available, both for targets and AIMS's players. Works from Unity 2022 up to Unity 6 at the time of release. New updates for compatibility will be rolled out as needed. Works with all render pipelines and uses shader graph for that. Works in multiplayer with local player authoritative config, but automatic integration with the input processor does not work on local split-screen multiplayer. With that said, let's see the new features for the AIMSs themselves. In the following section, I'm going to detail the AIMS's functionality. Description for each control can be found in the PDF documentation that comes with the package. Magnetism rotates the player controller to compensate for the player's strafing movement. This is useful when you are trying to AD strafe a target, where otherwise you would have to look back and forth to keep track of the target yourself. The script supports mirror or counter strafing by having different smoothness values until you face the target and after you have passed it. Those 2 values are interpolated along a certain percent of the AIMS's radius, so the transition between the 2 is not abrupt. The script's aggressiveness can be set separately for moving towards and away from the target, as well as horizontally. Motion tracker automatically tracks the enemy's movement. This is done in a way that the player can still pre-aim and let the enemy walk into the crosshair. This script, same as magnetism, has 2 interpolated values that define its aggression. One when the enemy is about to step into the crosshair, and one that is used to drag the crosshair after the enemy. Unlike magnetism though, motion tracker does this along the vertical axis as well, so aiming from high ground tracks the enemy all the same. The script's aggressiveness can be set separately for cases when the enemy is walking into your crosshair, or you are trying to keep track of it afterwards. Aim lock is an aimbot that keeps turning the camera to look at the center of the target. Time to aim can be set, and there's an interpolation with a smoothing curve available to get the desired effect. Auto aim pretends as if the player was aiming perfectly towards the center of the target and changes the raw look input to gravitate towards the target more. Naturally, the player has to be aiming at the target at least to some degree. This angle is a threshold that is set as a configuration for the script. And of course, its strength can be configured as well, ranging from a minimal nudge towards the mark all the way to basically overriding the player's look input. Precision aim is a fairly simple script that slows down the player's look input when a target is found. To avoid an abrupt change back to the original sensitivity with a pop when a target is lost, it gradually removes the assist over time on losing the target. Amazing is extremely simple, so much so that it is active regardless of finding a target, so it has no target selector. It is used to avoid an unwanted diagonal aim, and it does this by picking the more dominant look axis and scales down the other one. Suppose your player wants to look at the right, but the input isn't perfect and you would end up looking to the right and a bit up. Amazing in this case takes the up component of the input, scales it down, and the end result is a more accurate turn to the right with a minimal look to the up. Each aim assist has its own target selector and it finds targets on the designated target layers, while its sight is blocked by the designated map layers. Make sure to put all your aim assist targets on the target layer, and only these will be queried for the component, which is later cached. Spherical projection will shoot progressively smaller spheres until they run out or find a target. This helps finding targets behind cover. Consult the debug drawers if you wonder how your configuration will look like within the scene. Once you have your settings, you can disable the detailed mode to get rid of the clutter. Cone projection will shoot lines in a cone shape. The density of these lines can be set, and an additional sphere with configurable radius can be shot on top of them to really ensure finding targets, and if you don't want to go crazy with the line density. Once you have this set up, you can also set the debug drawer to only show a clutter-free overview of the cone. For a target to override how an aim assist supports it, enable the config in the aim assist target component. First enable the override, then you can optionally disable the aim assist if you want it to. Find the settings below that will take place only for this target once override is enabled. Naturally, the target selector cannot be configured for each target because at the time the target isn't found yet. Next up, let me show you two examples of manual integration where automatic integration is only partially or not at all possible. An excellent package where automatic integration unfortunately isn't possible is the Easy Character Movement 2 by Oscar Garcian. This package has its own internal mechanism to handle look input, and as such, internally set values are overwritten to store the current rotation for a frame. Luckily, this package also exposes an easy-to-use API to get around this. I got the default demo scene set up, and ECM2 and aim assist are both imported. On the designated target here, let me hit right-click, find aim assist in the game object window and make target. This should bring up the target creation dialog. First option is the layer that will be assigned to the target, and the second is the type of the collider to make if the target doesn't already have one. After creation, the layer is set and the aim assist target component is added. Now let me head over to the player game object. First up, let's open up the input action asset that controls the player and see the look action that has aim assist input processor added. Now with the player selected, hit right click, aim assist, add aim assist to bring up the bootstrap window. Here you can select the aim assists with the debug drawer to add. I'll pick magnetism as an example. Right off the bat there's a warning. It states that aim assist layers are not set up, so let me select a layer for the target. Once I pick default, there's another warning that states that the player is on the same layer as the target, which might cause issues. To fix this, let me put the player on its own layer. See that the warning is gone. Once I select a layer for the map as well, all warnings are gone. Next up, let me add precision aim to test the input processor as well. We can use the automatic physics info and no automatic integrator this time. ECM2 will need its own implementation that I will show you in a second. Bear in mind that the aim assist configurations still need to be set up in the scripts to get meaningful results. Last but not least, let me add the ECM2 rotational integrator I made. Since ECM2 has a well-designed API, this script is very short. I reference the character controllers and add my delta rotation to the control. Once I enable play mode, you can see that precision aim is working. Look input is indeed slow around the target. You can also see that magnetism is working too, as the player sort of orbits around the target sphere. Photon Engine released an excellent asset that is also free at the time of writing, BR200. The reason no automatic aim assist integration works for this asset is that it doesn't use input system, and the character controls directly set and overwrite a value that's replicated over the network from the input authoritative local player. To resolve the first problem, class agent input has a method process standalone input that is responsible for local player input, and this can be changed to support the aim assist code. I had run the mouse polling code through the aim assist input manager's aggregator code. In AIM Assist Pro version 2.0, using this input AIM Assist Manager singleton is a lot more straightforward because no direct references to the AIM Assist scripts are needed. I set up the soldier prefab akin to ECM2, and this time I added aim lock too. I also wrote a simple script to spawn an AIM Assist target cube near the player on level startup. I added a BR200 rotational integrator component that's a subclass of network behavior. Override its fixed update network method and use add loop rotation of the KCC class to implement an input authoritative rotation. Notice that now, unlike in the previous version, no direct aim assist script reference is needed anymore. When play mode is enabled and the level is loaded, you can see that input is once again slow around the target, and the character rotates to look at the target on its own. Thank you for your attention and good luck on your future games.